Quiz tomorrow will cover lesson 7.1, 7.2, 7.3. There are 11 questions. You will have a couple questions from 7.1 where you're just going to straight up have to use Pythagorean theorem. A squared plus B squared equals C squared. You will have to find a missing piece, either a leg or a hypotenuse. You must leave your answers in simplest radical form. You will not be able to just hit the square root button and round it. So all answers for missing legs and hypotenuse must be in simplest radical form. So in this case, on questions 1 through 6 here, that's what you're doing, is finding either a missing leg or a hypotenuse. You will also have to find the area of a triangle. So you will have to find the missing piece first and then find the area of the triangle. Remember, the formula for area of a triangle is 1/2 base times height, or you can memorize it as base times height divided by 2. So you'll find the missing leg or the missing, in this case it'll either be a missing leg, because remember you're multiplying the two legs. That's the base and the height. You will not be using the length of the hypotenuse. So from this lesson, I think there's 3 questions, 2 finding missing leg or hypotenuse, and then an area question. A radical with a regular number? Yeah. The regular number stays outside of the radical and the radical stays itself. So like for example, if you did square root of 3 times 6, this would just become 6 square root 3. When you multiply radicals with radicals, you multiply insides with insides and outsides with outsides. Meaning, like for example, if you did 2 square root 3 times 4 square root 5, you would do the 2 outside numbers and then the 2 inside numbers. Okay? All right, so find a missing piece, either a leg or a hypotenuse, and then also find the area. Then from 7.2, you're using the converse. So in this lesson, you are going to decide if the triangle is acute, obtuse, or right. So if you look at example 2 here, if the two numbers, when you square them, the A and the B, if it equals C squared, it's a right triangle. If C squared was greater than A squared plus B squared, then it's obtuse. If C squared's smaller, then it's an acute triangle. So you will have 3 questions. Okay, the questions, they may not be one of each. Everybody hear what I'm saying? Some of the versions have acute, obtuse, and right. Some of the questions have all acute, or some of the questions have 2 acute and 1 obtuse. So anything goes. Don't automatically assume that you're going to have one of each. Everybody heard what I just said? Yes, Michael.
So acute, what was acute in the obtuse?
Okay, so when you do the equation, so like for example, if I had, so let's say this was a 3, 4, 5, and they said, and they're not going to give you a picture. Just know I'm going to give you 3 numbers, and I'm going to say, do these three numbers form a right, an acute, or an obtuse? So what you're going to do is you're going to take the smaller 2, square them, and then we don't know what goes in here yet. We don't know if it's an equal sign, a greater than, or a less than. And actually, when I did this in the notes, I put the C squared first. So I'm going to do 5 squared, my blank line, 3 squared plus 4 squared. 25, my blank line, 9 plus 16. Because 25 equals 25, it's a right triangle. Now, let's say we did another one where, let's say C squared was, let's say it's a 3, a 4, and a 7. Would this work? No, let's make it, those numbers aren't going to work. Let me fix this. They would not even satisfy a triangle. So let's do different numbers. Let's do one of the examples here. So for number 5 here, I have the numbers 8, 21, and 27. So I'm going to take the largest one, put it here. I don't know what symbol goes in here yet. 8 squared and then 21 squared. 8 squared is 64, 21 squared is 441, and 27 squared is 729. I now have to add these two, 441 plus 64, and I get 505. Since c squared is greater than a squared plus b squared, it makes it obtuse. If c squared were smaller, then it would be acute. So you're going to have to put it into the Pythagorean theorem and see what c squared is. If c squared's bigger, it's obtuse. If c squared's smaller, acute. If it equals, it's right. Yes?
Why did you make 27C?
Because it's the biggest number. So when you're given, and this is how you're going to be given, I'm going to give you 3 numbers. The biggest number is c. Automatically assume that that's your hypotenuse. Good? So you'll have 3 questions like that where you're going to look to see what type of triangle it is. And then, let's see, number 5. And from 7-3, you are going to be given 2 numbers where you're going to have to calculate a geometric mean. So for example, it's going to say, find the geometric mean of 3 and 25. So when it says find the geometric mean, you just take the 2 numbers and you're going to multiply them and then square root it. So this gives me 75. Because 75 is not a perfect square, I got to break it down. Now, remember when I taught you this, I told you instead of multiplying, but you guys are using a calculator, so it doesn't really matter. But I could have left it like this apart and then factored them right here. And then as soon as you realize you got a pair here, one of these comes out, and then anything else that didn't pair up stays behind. So the square root of 75 would simplify to 5 radical 3. So again, you're going to break down the radicals. Also remember when you are squaring a radical. So like for example, if I said the square root of 5 squared, remember when you do that, it just comes out. But if you have something like this, remember the exponent goes on the 2 and on the 5. So this would actually become 2 squared, which is 4, and then the radical 5 squared turns into 5. And then you multiply it and get 20. So this is just a quick review of working with radicals. Okay, so also from 7-3, you're going to calculate a geometric mean. You're going to have to write a similarity statement for the 3 triangles. And then you're going to be missing an altitude, a segment, and a leg. And that is what is on your quiz. Let's see what the next. Writing a similar, oh, here it is. All right, so for example, I'm going to give you this figure here. And then you have to write the similarity statement. I recommend you pull the triangles apart. Remember in the homework how we had to reorient them and put them in the same orientation, meaning put the right angle in the same spot. So see how after you pull these 3 triangles apart, the original red, then you got this little blue one, and then you got this little green one. They've taken the green one, oriented it this way with the right angle down here in the bottom, then the blue one, and then the red one. If your letters are not in the right order, then you're going to get this question wrong. So all you're doing is writing this similarity statement. The easiest way I found it is to find the hypotenuses of the 3 triangles and start from there. That would be a good way to match. But then just match the correct smaller angle. And then you can just double check that all your right angles are in the right spot. Yes?
So when we're finding like the segment altitude or leg, is it going to be like in the triangle, all we have to find is the segment or the altitude or the leg, or is it going to be like find the altitude and the leg?
It's going to be a separate question. So a separate one question for altitude, one question for leg, and they're all going to be different pictures.
And then what's the difference between a leg and a segment?
Okay, the leg Okay, when we're referring to these legs, we're always talking about the big triangle. So for example, here is my original large right triangle right here. So when I'm referring to legs, I'm talking about the legs of the original. So the legs of my original triangle, because here's my right angle, and you know the legs make up the right angle. So these are the legs. The hypotenuse is the hypotenuse of the original large. Then the segment is the two little pieces that the altitude, when it was dropped down, creates. So it's the piece of the two pieces of the hypotenuse. So this could be, and it doesn't matter, you can interchange these. This could be 1, this could be 2, or you could say the other one, the GF is segment 1. It doesn't matter. So when we're referring to legs, we're talking about the two original legs that made the right angle of the big one, and then the hypotenuse, which is opposite that 90 degree. And then notice this altitude here is what breaks up the hypotenuse into segment 1 and segment 2. Does that make sense? And then remember when you're doing that, the proportion where you were doing the hypotenuse over leg and leg over SOHAL, segment of the hypotenuse. So remember, if I were using this proportion and I was using this leg, then that SOHAL is this right here. But for this leg, it would come around and grab this segment because it's the segment of the same triangle. Is that making sense? All right. Again, hardest part, I think, of this entire quiz is going to be breaking down the radicals if you haven't practiced that enough. Otherwise, the proportion should be pretty straightforward. Yes?
Do we need to use the quadratic formula?
No. You will not have anything that you have to factor on this quiz or use the quadratic formula. Okay? And you won't have to FOIL anything. It's just going to be basically square rooting. Everybody understand that? So like I know in the homework, some of those problems were really intense. However, these are going to be pretty straightforward. It's just going to be breaking down radicals. 11 questions. Just know the proportions and know the Pythagorean theorem and know how to write that similarity statement. And then on Wednesday, we will start 7-4. We'll continue on with Chapter 7, and then your test on Chapter 7 will be next week. Any questions? Okay. Thing is here. So these are all good examples. Okay. Let me find one in the homework that showed that. We did it in the homework. So there isn't any on the study.